Time series applications in data mining presented by Group 1. Now let's see what a time series is. A time series is a sequence of data points that occur in successive order over some period of time. A time series tracks the movement of the chosen data points such as securities price over a specified period of time with data points recorded at regular intervals. In time series, there is no minimum or maximum amount of time that must be included, allowing the data to be gathered in a way that provides the information being sought by the investor or analyst examining activity. Time series has 4 components as given below: level, trend, seasonality and noise. Level: it is the mean value around which the series varies. Trend: it is the increasing or decreasing behavior of a variable with time. Seasonality: it is the cyclic behavior of time series. Noise: it is the error in observation added due to environmental factors. Now let's look into some key points in time series. A time series is a data set that tracks a sample over time. In particular, a time series allows one to see what factors influence certain variables from period to period. Time series analysis can be useful to see how a given asset, security, or economic variable changes over time. Forecasting methods using time series are used in both fundamental and technical analysis. Although cross-sectional data is seen as the opposite of time series, the two are often used together in practice. Now let's look into some advantages of time series. First one is the trend analysis. By just plotting data against time can generate very powerful insights. A very basic use of time series data is just understanding temporal pattern or trend in what is being measured. Example, in businesses, it can give an early indication on the overall direction of a typical business cycle. Second one is the outlier anomaly detection. An outlier in a temporal dataset represents an anomaly. Whether desired or not, outliers can be detected in a dataset can help prevent unintended consequences. Third one is in examining shocks or unexpected variations. In time series data can identify variations expected or non-expected or unexpected and anomalies. Detect signals in the noise. Association analysis. By plotting bivariate or multivariate temporal data, it is easy to identify associations between any two factors. This association may or may not imply causation, but this is a good starting point in selecting input features that impact output variables in more advanced statistical analysis. Forecasting and predictive analytics. Forecasting future values using historical data is a common methodological approach. Predictive analysis. Advanced statistical analysis such as panel data models, fixed and random effect models rely heavily on multivariate longitudinal data sets. These types of analysis help in business forecast, identify explanatory variables, or simply help understand associations between features in a data set. Now let's look into some applications of time series. First one is in financial analysis. It includes sales forecasting, inventory analysis, stock market analysis, price estimation. Second, network data analysis. It includes network usage predictions, anomaly or intrusion detection, predictive maintenance. Third, in weather analysis. It includes temperature estimation, climate change, seasonal shift recognition, weather forecasting. Fourth, in healthcare analysis. It includes census prediction, insurance benefits prediction, and patient monitoring. To capture the time series components, there are a number of popular time series modeling techniques. Some are listed below. Naive methods. These are simple estimation techniques such as the predicted value is given, the value equal to mean of preceding values of the time dependent variable or previous actual value. These are used for comparison with sophisticated modeling techniques. Autoregression. Autoregression predicts the value of future time period as a function of values at previous time periods. Predictions of autoregression may fit the data better than that of naive methods. but it may not be able to account for seasonality. Next is the autoregressive integrated moving average models, abbreviated as ARIMA model. The value of a variable has a linear function of previous values and residual errors at previous time steps of a stationary time series. However, the real-world data may be non-stationary and have seasonality. Thus, seasonal ARIMA and fractional ARIMA were developed. ARIMA works on univariate time series to handle multiple variables. ARIMA was introduced. Exponential smoothing. It models the value of a variable as an exponential weighted linear function of previous values. This statistical model can handle trend and seasonality as well. LSTM, long short-term memory model, is a recurrent neural network which is used for one-time series to account for long-term dependencies. It can be trained with large amount of data to capture the trends in multivariate time series. These said modeling techniques are used for time series regression. This is the end of our presentation. Thank you.